Hello students, I hope you're having a wonderful day. Today I would like to complete a practice problem that involves static friction and the coefficient of static friction. So let's go ahead and get started. You are dragging a box full of books from your office to your car. The box weighs 7 newtons and the books weigh 135 newtons. If the coefficient of static friction between the pavement and the box is 0.55, what force must be applied to the box in order to move the box? Now, before we perform any calculations, let's go ahead and generate a column of knowns and unknowns. Let's draw a simple picture and then let's draw a free body diagram. Okay? So, the box weighs 7 newtons and the books weigh 135 newtons. And the coefficient of static friction between the box and the pavement is 0.55. So let's go ahead and record some values. So we have coefficient of static friction, 0.55. So we're going to use the lowercase Greek letter mu, and I'm going to use a subscript of S to indicate static friction for the coefficient of static friction, that's 0.55. We have the weight force of the box. So weight force is identified by F sub G. I'm going to use a subscript box, 7 newtons. And weight force, we know that the vector points in a negative y direction, so we can put a negative sign on it, or we can just draw our vector arrow. And we also have the weight force of the books. So F sub G sub books. This is 135 newtons. And remember, that arrow points in a negative y direction. Okay, so it says you are dragging the books. If we were to draw a very simple picture, we have the box of books, and your applied force, you're pulling the box. So let's say the applied force vector is in the positive x direction. And there's our static surface, the ground. Okay, now let's go ahead and draw a free body diagram. So when we have a free body diagram, let's go ahead and start out with the weight force. So here's my system, the box. And we have a total weight force. So I'm going to say F sub G sub T for total. The total weight force is going to be the sum of the weight force for the books and the box. So 135 newtons in the negative y direction plus 7 newtons in the negative y direction. We have 142 newtons. And our vector arrow is pointing in the negative y direction. Now in the y direction, our system is in equilibrium, so that means that the ground is pushing up on the box of books, 142 newtons. So normal force applied to our box of books. Normal force is identified by F sub N. This is 142 newtons. And we are applying a force here, F sub A. And we have a static friction force. So friction force identified by F sub F. I'm going to be a little bit more specific and add another subscript of S to identify the static friction force. Okay, so it tells us that the coefficient of static friction is 0.55. We know that the coefficient of static friction is equal to the static friction force divided by the normal force applied to the object. Now our unknown here is the static friction force. So what I'm going to do is isolate this variable by multiplying by normal force on both sides of the equal sign. So when we do this, the normal force on the right side of the equal sign cancels out. We have one in the denominator and one in the numerator. So we've isolated our static friction force. So our static friction force is going to be the product of our normal force and our coefficient of static friction. So what we have, normal force, we need to refer to our free body diagram, 142 newtons. And we are going to multiply this by our static coefficient of friction, which is 0.55. So you need to get your calculator out. So 142 times 0.55. This gives me 78.1. And we have units of newtons. So right here, let's go ahead and label it over here, 78.1 newtons, okay? Now it's very important to draw this free body diagram so we can visually see really what's going on. And it asks, what force must be applied to the box in order to move the box? Well, let's say if we applied 78.1 newtons, if we applied this to the box, we need to ask ourselves what would happen, okay? So would the box accelerate in the negative x direction? Would the box have zero acceleration? Or would the box accelerate in a positive x direction? Well, let's refer to Newton's second law of motion. And we know that Newton's second law is directly proportional to the net force applied to the object and inversely proportional to the object's mass. Well, looking at our diagram here, if we have a static friction force of 78.1 newtons, and we're just saying we're going to apply 78.1 newtons, what is our net force? Well, our net force is 0. And since our acceleration is directly proportional to the net force, well, if this is 0, our acceleration is 0. So the box does not move in this situation. But if our applied force is any force greater than 78.1 newtons, we will have an acceleration in the positive y direction. So we'll just be able to move the box. And that's how we need to answer our question. Okay, so what force must be applied to the box in order to move the box? So we can say the force must be greater than 78.1 newtons. And that is our answer right there. Even if we had something like 78.2 newtons, which is greater than 78.1, only by 1/10 of a newton, this would cause a net force applied to our box. And so we would have an acceleration in the positive x direction, so we could go ahead and move the box. So I hope this video helps you out. If you have any questions, please send me an email or call me. I hope you have a wonderful day.